Welcome to Chapter 8, Section 7, Surface Area of Prisms and Cylinders. Our objective in this unit is to find the surface area of prisms and cylinders. We have 3 vocabulary words, and the first vocabulary word is surface area. The surface area is the sum of the areas of all surfaces of a figure. Now by using the word sum, we realize we're going to add the area of each of the surfaces. So for surface area, you can kind of imagine the fact that you might be wrapping a present. And the surface area is the part that you're covering so no one can see what's inside. Lateral faces, sometimes referred to just as the word face, of a prism are the parallelograms that connect the bases. Where the lateral surface, when dealing with a cylinder, is the curved surface. The lateral surface, another way of thinking of it, is think of a can of soup. And when you take the wrapping off, that label off, and unwrap it, it becomes a rectangle. But it's also the lateral surface, that label is the lateral surface of the cylinder can. Here's a more formalized version of everything. The surface area of a prism is twice the base, in other words, it has 2 bases, the top and the bottom base, plus the lateral area. The lateral area F is this part right here. This part, this part, this part, and this part, which ends up being right here. Okay. We provide 2 formulas here. I prefer the top one. I usually find the area of each base, and then I find the area of each of the faces. For cylinder, I prefer using this formula. But the surface area of a cylinder is twice the base. Once again, we have the top and the bottom, plus the lateral area, and this rectangle is the lateral area. Let's talk about how we get this. If we choose to use this formula, our bases, in both cases, are circles. The area of a circle is pi r squared. So our base is this part right here, pi r squared. And of course we have 2 of them, the top and the bottom. So that's how we get the first part. Then we have the plus sign and the lateral surface. Now this is a bit trickier to describe. As a lateral surface, it's a rectangle. The area of a rectangle is base times height. The height part is easy. The height part in this case is 6. But the base is unknown. The base is this length right here. Well, that length is going to be the same as the circumference of the circle. If you remember, the circumference of a circle is going to be 2 pi r. So if we bring the h straight down, and this represents 2 pi r, there's the second half of our equation. So our lateral surface, or this rectangle, will be the 2 pi r times height. Let's try using it in an example problem. Notice, like I expect you to do on your paper, the formula is written down each time. The surface area of a cylinder is 2 pi r squared plus 2 pi r times height. We need to look for our r. Our r is a radius. In this case, it's 4 inches. So we're going to fill that into the r spots. And we also need to know the height. And the height is 6 inches. So fill it in the h spot. Now, when we fill numbers in for the letters, the variables, it's just like we did in Chapter 1, where you just fill them in place, and then you apply the order of operations. When we solve this using order of operations, we have 4 squared, which is 16. 16 times 2 is 32 pi, plus 2 times 4 times 6, well 4 times 6 is 24, times 2 is 48 pi. 32 plus 48 is going to be 80 times pi, inches squared. So that's the same as saying 80 times 3.14. Okay, looking at B, notice this is not the way I like to do this. I would prefer to do 2 times the base, which we'll talk about in a minute, plus side 1, plus the length and width of side 2, plus the length and width of side 3. Let's look at the bases. This is your base. This is a triangular prism, so your base is a triangle, which means your formula for the base is 1/2 base, in this case the base is 8, times height. The height is 3. And then we're going to add the area of each face. The first face we're going to add is going to be this face right here, which is 5 times 10. Now we're going to add the second base. Second base, the second face is going to be right here. Notice this one's 5 tall and 10 long as well. So this is going to be 5 times 10. And then finally we're going to look at the third base. And the third face is going to be right here, which is also the base. And that's 8 by 10. So we're going to do plus 8 times 10. So when we multiply this through, the 1/2 times the 2 cancels and makes 1. We have 24 plus 50 plus 50 plus 80. So we have 204. Let's look at example 2. In example 2, we're looking at a cylinder that has a diameter of 8 and a height of 3. Now for our formula, we don't need diameter, we need radius. Well, we know the radius is half the diameter, so our radius is going to equal 4. So we're going to put 4 in for our radius in each spot, and our height is equal to 3. Multiply that out, we get 56 pi. 56 times 3.14 is going to equal 175 and 8/10 inches squared. Now, what we need to explain is whether tripling the height would have the same effect on the surface area as tripling the radius. So let's take a look. We're going to triple the height, triple H. So we did 3 times 3, which equals 9, because our height was 3, was by 3. Again, multiply this out. This would be 32 pi. Multiply these out. We realize that we get 326 and 6/10 inches squared. Then we're going to triple the radius. We have a 3r here. So 3 times r, radius was 4. That's 3 times 4 is 12. Again, in both places. Multiply it out. 360 pi. 360 times 3.14 is 1,030 and 4/10 inches squared. So we now see, looking at this, they would not have the same effect. Tripling the radius would increase the surface area more than tripling the height. Let's look at example 3. We have a soup can, 7.6 centimeters in diameter. Again, divide that in half, and we realize the radius is 3 8/10 and 11 2 centimeters tall. What's the area of the label that covers the side of the can? Well, remember we talked about this, and this was a rectangle. And a rectangle equals base times height. Well, our base is going to be 2 times pi times r, because it's the same as the circumference of the circle. If you need to, back this up and listen to that part again. So we have 2 times pi times r, which we decided was 3 8/10, times our height, which is 11 2/10. We've already talked about how half the diameter is going to equal the radius. Multiply these together. We're going to get 85 and 12/100 pi. 85 and 12/100 times 3.14. And your answer is 267 and 3/10 centimeters squared. You have a single try this problem. I've already written the formula you need down. You need to go ahead and fill in the necessary spaces and solve this problem. Stop the video, please do that. I will see you in class tomorrow.